Welcome to episode 4 of Concept into CAD. I'm Brian Zayas. We left off a few weeks ago before we had enough time to finish taking our conceptual wall-mounted system all the way to detailed design. So today, that's precisely what we're going to do. Now joining me to do most of the hard work, my colleague Brad Williamson from Nashville. Good morning, Brad.
Hey, Brian. Tell you what, I'm excited to get this project finished up.
Yeah, totally. Hey, 1 second though, I just got some feedback on the community. Patrick notes that he agrees the arms look way over-designed, but also makes a good point that maybe 8 arms is too many. We could get away with 4. What do you think about that?
Well, I'd have to agree. I guess having that many arms is probably overkill, and it is a lot of extra parts to have to machine. I've modified that concept to a thicker 2-arm design. The overall envelope of the new arm is bigger, but I can use some cut extrudes to remove material and imply a little more of a stylized shape. I know the dimensions I want for the overall height, but I'll leave the shape pretty basic for now so Brian can add more detail in SOLIDWORKS. I'll use the sketch profile to make a through-all cut extrude and do the same thing again on the top side of the part. However, that second cut leaves a little bit of an undercut, so I'll need to add some material back with an up-to-next extrusion. Looking at the top view, I'll draw a contour to give it a bit of a dog bone shape and then select these interior edges and apply a generous fillet for stress relief. I'll then select the outer edges and apply more of a cosmetic fillet. We don't need this hole anymore either, so once that's gone, the rough detail design of the mounting arm is basically ready for Brian to apply the finishing touches in SOLIDWORKS. Heading back to the assembly, we want to take this mounting bracket and give it more of a blocky shape, thinking that we might be able to use sheet metal or bent plate for the final design. I'll extrude a rectangle overlapping the existing shape. Now I'll add a couple of edge fillets to represent the sheet metal bends and shell the part to a constant wall thickness. The bracket's still a little bit too tall for the new arms, so I'll just grab the dimension handle and shrink it down to size. Repeat that process for the front mounting bracket and we have a concept that's ready to save to SOLIDWORKS, and we have a great launching point to begin the detailed design.
Brad, I am digging that swoopy shape. I'm going to open up SOLIDWORKS 2014 now and take your design one more step. Components like these pins were great placeholders in concept, but need to be replaced with purchased hardware. Alright, let's focus in on that arm design now. I may want to start by adjusting Brad's features, like changing this fillet here from 2mm down to 1. Next, I'm going to create a reference axis in each hole to prepare it for a standard countersunk drilling feature that I've stored over in my design library. This will easily bore out the starter half-inch holes for the hardware stack. Threaded inserts, bushings, washers. Brad, I think you have a good idea of what we need here. Now let's turn to the issue of over-design and cut away some unneeded aluminum. I'm going to start by using an offset sketch to capture the contour that Brad created in Mechanical Conceptual. Using tangent arcs, I complete the profile and add relations and dimensions to capture my full design intent, including making sure that my offsets are correctly linked to the holes and the fillet edges to make sure that any changes we need to make in manufacturing can easily be updated. I extrude cut this from the center but offset it a little to leave a few millimeter rib. After adding a 2mm face fillet, I mirror this to the other side, start a new sketch, and once again offset edges, and then cut all the way through. Going back to the fillet tool, let's add in some 2mm finishing fillets, and then also treat the final outer rough edges with a 1mm fillet. Finally, let's apply an aluminum material and then flip back over to the assembly. Brad, this is starting to look pretty good, so what's next?
To connect the arms, we'll need a threaded insert, bushings, a washer, and a cap screw. A section view shows how everything fits. The mounting bracket up front is also recognized as sheet metal. We'll add a couple of slot cutouts, then unfold the remaining bends. Fast forward a little to finish the part details and add in a fastener stack. Remember the sheet metal bracket we made in episode 3? We'll fold out a mounting flange, then install a hardware kit, and we now have a design that will allow the display to pivot forward and back. Mass Properties shows that the assembly weight is only about 6 pounds because all the major parts are aluminum. Assembly Visualization gives us a color map to show which parts are heaviest. We can also create a visual sort on other parameters like which parts we make versus buy. We'll run SOLIDWORKS costing to get a detailed manufacturing cost estimate, even down to the piece part level. Just a couple more things to do. I found a motorized rail system from a supplier on 3D Content Central. It's rated for a 225-pound load, so we should be in good shape, and as you can see, we've got all the range of motion we require. We can now mount the 70-inch display, but before I create any detailed drawings, we'd better run a final simulation to make sure the design is strong enough.
Well, Brad, with that actuator, what if the motor suddenly stops? this is no longer a static simulation, so I'm going to turn to linear dynamics to apply inertial loading. I'm going to suddenly decelerate from 12 inches per second down to 0. The transient response shows the displacement overshooting the static case by about 30 thousandths of an inch. That's okay with me, but let's look at the stress. This is also slightly higher, so let's probe the response of the stress hotspots. Again, looking over time, this stays right below 60,000 psi. We might want to lower this a gauge or two. The reaction force shows that the actuator will need to withstand a peak 200 pounds in-plane force. This actually coincides with the manufacturer's recommended max. Taking a look at their data sheet, this is going to allow us to raise and lower at 1/2 inch per second. Time to post my results to the community and make some suggestions. Number 1, let's beef up that back sheet metal bracket. Number 2, let's invite an expert to the community on linear actuators to help improve that design. Then, let's go out and get that finished drawing package completed.
So Brian, what do you think about that final drawing package?
Brad, awesome work, man. But it should come as no surprise that SOLIDWORKS enables us to create all this detailed production-ready output. But we did invest a lot of time precisely and parametrically capturing all that manufacturing and design intent.
Not as much as you might think. I've got about 8 hours of real time into the assembly design and the finished detailed drawings. And of course you did that dynamic simulation. But you know, I'm glad that we only had to do this once because we had such a good launching point from our concept work in Mechanical Conceptual. Looking back on where we've been in the last few weeks, we started using Mechanical Conceptual to come up with a pretty simple monitor mount for an LCD screen. That morphed into a motorized whiteboard mount, which then turned into a completely innovative design for a movable, large format interactive display.
So Mechanical Conceptual allowed us to rapidly iterate, share, and get feedback on our ideas, probably most importantly, respond flexibly to the design requirement change for the giant touchscreen. That was really the key to our innovation here. Lots of fast ideas and getting that feedback on the community before we got too focused in on all the manufacturing and design intent that ultimately we needed in our detailed design. Brad, I am super stoked. Great job on this project.
Well, that's all the time we have for this episode. But if you'd like to download the detailed SOLIDWORKS assembly and drawings, just click the link below. Thanks for joining us on this episode of Concept Before CAD, and we'll see you next time.